Section 7.6, Modeling with Trigonometric Equations. In this section, you will determine the amplitude and period of sinusoidal functions, model periodic behavior, and solve real-world applications involving trigonometric functions. In this section, we will get to put all our trigonometric knowledge to work by modeling periodic motion and solving real-world problems that involve trigonometric functions and concepts. Now let's recall that we previously learned about the standard form of sinusoidal functions. And these general forms for sine and cosine, y equals a sine of b t minus c plus d, or y equals a times cosine of bt minus c plus d, where a is the amplitude, absolute value of a, b is related to period such that the period is 2 pi over b, and c is the phase shift such that c over b denotes the horizontal shift and d represents the vertical shift. Example number 1. Find the amplitude and period of the following functions. Also write the equation of each. So let's start with letter A. And to write an equation given graph, if it's sine, you always start at midline. And for cosine, starts at the top. That is, you have to take a look at your a. If a is greater than 0, that is at the top or at the bottom. That is if your a is less than 0. Okay, so take a look at letter A. Starts at midline here. So this is the midline. So definitely we're going to use sine. So we expect that it's going to be y is equal to a sine of b t minus c plus d. Now, let's identify what A, B, C, and D are. First, the amplitude. And we note that this is the amplitude. This is the amplitude. And the length of this is 2. So meaning the amplitude, the absolute value of A is equal to 2. So next is, how do we find B? So we know that B is equal to 2 pi over the period. And take a look at this. One period of a sine. This is your sine graph. That is from 0 to 8 pi. So that means this is equal to 2 pi over 8 pi. So that is, your period is equal to 8 pi. And let's simplify this. Pi over pi, 2 over 8. So B is equal to 1/4. Then we start at 0 here from 8 pi, that is 1 period. We can say that there is no phase shift. That means C is equal to 0. And D is the midline. So the midline is at 0. So midline t is equal to 0. So now we can write our equation. So that is y is equal to, our a is 2, sine b is 1/4 of t. There's no phase shift, that is 0, and there is no midline, which is also 0. So this is the equation of this graph. Y equals 2 sine 1/4 of t. Okay? Then letter B. The first question is this graph a sine or cosine graph? So remember, it starts at the top. So definitely it is cosine. So that's why we're going to use y is equal to the general form a times cosine of b of t minus c plus d. So now how to get our a, b, c, and d. So next is the amplitude, which is equal to the maximum minus the minimum over 2. So with this, what is the maximum? That is 5, and minimum is -1. So 5 minus -1 over 2, and 5 minus -1 is 6 over 2. So this is equal to 3. Your a is equal to 3. Next one is d. You can solve for d using the max and the minimum. That is actually the average of the two. So this is the minimum plus the max over 2, and that is, again, minimum is -1 plus the maximum is 5 divided by 2, which is equal to -1 plus 5 is 4 divided by 2 is equal to 2. So that is our d. Next, how about the period? The period here, as you can see, this graph from 0 to 2 pi. So you can say that the period is equal to 2 pi. And with this, we can solve for b. And we know that b is equal to 2 pi over the period. So that is 2 pi over 2 pi now, which is equal to 1. And phase shift, and this graph is from 0 to 2 pi, so meaning there is no phase shift. So c is equal to 0. So now we can write our equation. It's going to be y is equal to, our a is 3 cosine, b is 1, so 1t, and c is 0, phase shift, so that is just cosine t, and d is 2 plus 2. And also d is our midline, and take note of that. And this is the midline. Okay. We will now apply these ideas to problems involving periodic behavior. So example number 2, the average monthly temperatures for a small town in Oregon are given in the table below. Find a sinusoidal function in the form of y is equal to a sine b t minus c plus d that fits the data, and sketch the graph. So given the month from January to December and the temperature in degrees Fahrenheit. Let's start with A. That is, remember, it's the maximum minus the minimum over 2. So where is the maximum, the minimum here? So this is the maximum, and this is the minimum temperature. And let's solve that. It's going to be equal to 69 minus 42.5 over 2. So A is equal to 13.25 to be exact. Then we know that we have a period is equal to 12. We have 12 months, and we know that your B is 2 pi over the period. So P is 2 pi over 12. Simplify this. B is equal to pi over 6. What's next? About D. D is the average of the maximum and the minimum. So max plus minimum over 2. So this is 69 plus 42.5 over 2, and add and divide it by 2. That is 55.75. Or approximately 55.8. Now we can have y is equal to a, which is 13.25, sine of b is pi over 6, t minus c plus 55.8. Now we want to find c. So to find c, we need to plug in, let's say the first one, January, that is, this is the first month, so this is like a t is equal to 1. So this is 2, 3, 4 up to 12. So if we're using the first month, January, so that is, we have the coordinates 1 and 42.5. Now we can substitute this. This is your t, and this is your y. So we can substitute that here, and we can solve for c. So let's do that. So y is 42.5 is equal to 13.25, or let's use a 1 decimal since the given temperatures is in 1 decimal. So let's use approximately 13.3. So let's change this to 13.3. So 13.3 sine of pi over 6 times t is 1 minus c plus 55.8. So remember, we are solving for c. So next is subtract 55.8 that is negative 13.3 is equal to 13.3 sine of pi over 6 times 1 is pi over 6 minus c. Then divide both sides by 13.3. And that is equal to, this is negative 1 sine of pi over 6 minus c. And to solve for c, remember, we get the inverse sine, inverse trig both sides. So this will be inverse sine of negative 1 is equal to pi over 6 minus c. And inverse sine of negative 1 is negative pi over 2 is equal to pi over 6 minus c. Then it will be c is equal to pi over 6 plus pi over 2. And we simplify this, it's going to be equal to 2 pi over 3. So that's how you solve for c. Now we have a, b, c, and d. We will be able to write our equation. So y is equal to 13.3 sine of pi over 60 minus 2 pi over 3 plus 55.8. And that is, actually, this is the graph of that. Okay, so take note of this. Based on what we did for example number 2, only find z. That is after you have solved for a, b, and d. Okay, so take note of that. Only find a c after you have a, b, and d. Okay, next problem. Example number 3. The hour hand of the large clock on the wall in the Union Station in New York City measures 24 inches in length. At noon, the tip of the hour hand is 30 inches from the ceiling. At 3 p.m., the tip of 54 inches from the ceiling. And at 6 p.m., 78 inches. At 9 p.m., it is again 54 inches from the ceiling. And at midnight, the tip of the hour hand returns to its original position, 30 inches from the ceiling. Let y model the distance from the tip of the hour hand to the ceiling, and for x hours after noon. Now we want to find the equation that models this motion and sketch the graph. So our x, definitely this is the time, that is in terms of hours, and y is the distance in inches. So points to plot. So it says at noon, that is, let's say 0:30. At 3 p.m. we can say that this is 3:54. 6 p.m. 6, 7, 8 inches. 9, 54 inches. And now at midnight is again 30 inches. Let's say this is the clock, and this is the length here is 30 inches, and that's why at noon, that is from here to here at noon, is 30 inches. And let's say if it's at 3 p.m., so this is the clock, at 3 p.m. So meaning from here to here, because this is at 3 p.m. and at 9 p.m. So meaning the length here, the distance, is 54 inches. Now the big question is this a sine or a cosine? So let's try to plot these points. So we have the x values, let's say from 0 up to 12, 3, 6, 9, 12, 2, and distance highest is 78. So let's say this is 30, 40, 50, this is 70. So the first one, 0, 30, then 354, let's say here, then 6, 7, 8, let's say like here, and then 9, 54, and 12, 30. So here. So it looks like this graph it starts here, and then it continues after midnight, so it's gonna be continuous here. Do you agree? So it starts at the bottom second, because it starts at the bottom here, so that is a cosine, and it is actually a negative cosine. So that is a is less than 0. Okay, so meaning we're gonna use again y is equal to, I'm gonna write it here so that we have a space, a cosine of pt minus c plus d. And now how do we get our a, b, c, and d? So remember, a is equal to, that is the maximum minus the minimum over 2. Based on this, maximum is 78, minimum is 30 divided by 2, that is equal to 24. And since a is less than 0, so your a is going to be equal to negative 24. Okay. Next, the midline, which is your d. is the average of the max and the minimum. So 78 plus 30 divided by 2, which is equal to 54. So this is the midline, which is equal to 54. Then we know period is, so you have the clock that is from 1 to 12, so the period is 12, and we can now solve for b. 2 pi over the period, 2 pi over 12, which is, simplify this, it's just equal to pi over 6. And based on this, there is no phase shift. Based on our graph, so that means C is equal to 0. Okay, so now we can write our equation. So it's going to be y is equal to A is negative 24 cosine of B is pi over 6 t. There is no phase shift, that is 0, and our midline ND is equal to 54, so plus 54. And that's why this is that graph. Alright, next. Solving real-world applications involving trigonometric functions. We can use trig functions to use real-world problems that involve the behavior besides just periodic motion. Like example number 4. An airplane has only enough gas to fly to a city 200 miles northeast of its current location. If the pilot knows that the city is 25 miles north, how many degrees north of east should the airplane fly? So let's say the plane starts here and flying to a city 200 miles northeast of its current location. So that's going to be your hypotenuse with 200 miles. And the city is 25 miles north, so meaning this is 25 miles. And from here to east, and how many degrees of northeast should the airplane fly? So we want to get this data here. Okay, so this is the start and this is going to be the end. So if we have this angle, this is the opposite and this is the hypotenuse. So what do we need to use? So yes, it's going to be sine of theta is equal to the opposite, which is 25 over the hypotenuse 200, and to solve for theta, that is inverse sine of 25 over 200. So just use your calculator. Inverse sine of 25 over 200 is in degrees 7.18 degrees. So that is 7.18. Okay. Next example. Example number 5. A camera woman needs to film a rocket launch and get a perfect shot when the rocket is 11 miles in altitude straight up from the launch pad. If she sets up her camera 4 miles from the launch pad, due east, at what angle from the horizontal should set her camera? So let's say this is the launch pad and it's 11 miles in altitude. So this is 11 miles. And if she sets up her camera 4 miles from the launch pad, so we can say that this is 4 miles, then we can have this as the hypotenuse. So we want to get the angle from the horizontal. So this is that angle. And from this angle, this is the opposite side, and this is the adjacent side. So meaning we need to use, yes, tangent. So tangent theta, opposite over adjacent, 11 over 4. And to solve for theta, yes, we need to get the inverse tangent of 11 over 4. And again, use your calculator. Inverse tangent of 11 over 4 in degrees is actually 70.02 degrees. Okay, and that's it. Now let's work on some lecture questions. Number 1, outside temperatures over the course of a day can be modeled as a sinusoidal function. Suppose the temperature varies between 47 degrees Fahrenheit and 63 degrees Fahrenheit during the day, and the average daily temperature or middle temperature of 55 degrees Fahrenheit first occurs at 10 a.m. Now the question is, how many hours after midnight does the temperature first reach 51 degrees Fahrenheit? So with this, the given here 47 and 63, so meaning this 47 is the minimum and the maximum is 63. So with that, you'll be able to solve for our A, which is, you know that it is maximum minus the minimum divided by 2, and that is equal to 16 over 2, which is equal to 8. Same thing with the maximum and the minimum, we will be able to solve for our midline, or the D, that is 47 plus 63 divided by 2, that is 110 divided by 2, which is equal to 55. And the period, what we know about our period, that is the whole day, we have 24 hours. So now we will be able to solve for B, which is 2 pi over the period, 24 hours, and simplify that, it's going to be pi over 12. So also from here, it says that the first occurs at 10 a.m. So when t is equal to 0, that is at 10 a.m. So that means 0, that the temperature was 55 degrees. So this is our first coordinate. So here also there is no phase shift, because it starts at 10 a.m. that is when t is equal to 0. So now we can write our equation. So it's going to be y is equal to, a is 8, and this is sine of pi over 12 t plus 55. And to craft this, a rough sketch of this, it starts at 0. When t is equal to 0, it's 55. So this is 55. and that should be your D, and that is your midline, and it should look like this. Over the 24-hour period. Okay? And number 2. If a loading ramp is placed next to a truck, a height of 2 feet, and a ramp is 20 feet long, now what angle does the ramp make with the ground? So say this is 2 feet and this is the ramp of 20 feet long, and what angle does the ramp make the ground? So meaning we can get this angle here, and with this angle, this is the opposite side and this is the hypotenuse. So what do we use? Yes, it's sine theta. Sine theta is equal to opposite over hypotenuse, so that is 2 over 20, and to solve for theta is inverse sine both sides, so that is inverse sine of 2 over 20, and use your calculator, and that is equal to 5.74 degrees. Okay, and that's it for section 7.6 and chapter 7. Let me know if you have any questions. Thank you.